In this video, we're going to look at pressure effects on gas solubility. So let's just assume here I have a closed vessel, and we have a liquid down here at the bottom, and then there's gas on top of that liquid. And the gas can't escape this container, so there's going to be an equilibrium that's going to be established between the gas molecules above the liquid and then those molecules that are in the liquid. So the question is, what happens when we adjust the pressure? So if I increase the pressure of the gas inside this container, the question is, what impact does that have on the molecules inside there? So if we increase the pressure, we're going to increase the collisions between the gas and the liquid surface. Okay, so increasing the pressure, we're making the gas molecules hit that liquid surface at a much more rapid rate. Okay, so that means when we look at this equilibrium, that the rate of the gas to liquid portion of that equilibrium is going to increase. Okay, the rate at which the liquid goes into a gas stays the same. So by increasing the pressure, we can make the conclusion that the gas will be more soluble in the liquid when we increase the pressure. Okay, so bottling companies such as Coca-Cola use CO2 to carbonate beverages in this way. You know, when you open up the cap, you hear a fizz, the pressure of the gas releases out into the atmosphere, and we see the CO2 bubble out of the liquid. So what they do is they pressurize that gas, they make it more soluble, and when you open it up to a normal atmosphere that's not as pressurized, the CO2 in the liquid bubbles out and becomes a gas. So there's a relationship between solubility as a function of temperature. And this was studied and then was put into practice, and it's referred to as Henry's law. And Henry's law expresses the solubility equal to K, which is a constant, times the pressure. And this is going to be our solubility, which is typically expressed in moles per liter. K is referred to as Henry's constant, and this constant is typically expressed in moles per liter times atmosphere. Okay, and then P is our pressure. So this will allow us to determine what the solubility of a particular gas is as a function of pressure. And we'll do an example of this in the next video.